So today we're going to try and get the paddle shifters in the Camaro up and running. Let's talk about it. What's going on, everybody? Welcome back to the garage, and we're finally to the point of trying to get the paddle shifters to work. Now, there's a couple things I'll kind of show you what's going on here. Here's our center console that I kind of quickly just threw together and 3D printed. Nothing crazy. We've got our air conditioning control, turbo-lamic stuff here. This is just USB for the phone that goes into the radio, and as you can see, I put a just blank plate up in here. Then down on this side, we've got the plug-in for the core ECU and the turbo-lamic, but the paddle shifters that I picked up from Seems Legit, I wired those things into the turbo-lamic using multiplexer. Essentially, let's see if I can get the steering wheel button off here. There is resistors on this side of it. And so the horn and the paddles are all tied in on the horn's ground leg that would normally go to the relay on the horn. And then I jumped in on that. And so what we're doing is, instead of having to put a clock spring in here, we're using the existing clock spring for the horn circuit. So if you don't know how a multiplexer works, it's where we use resistors to create different voltages. And in this case, we're using a 5-volt pull-up resistor and then 3 different resistance values. And so whenever you hit one paddle, it generates one voltage. This one would be another, and this would be another one. Now, the turbo-lamic has built-in demultiplexing, as it were, but it doesn't work very well. So this is where we're going to come in and take a look at this cool little device that I bought and program. This is called an M5 stack, and this is the Core 2.7. This is the basic version. The fancier versions have touchscreen. This one just has some interaction buttons. And then I'm running this with the voltmeter. So we'll bring in our analog multiplexer there. And then this module that stacks in there, that's why it's called a stack. So this is the top module. This is the base, and then there's a relay module in here in the middle. So, and the cool thing about it is this base has a small battery in it, which we won't be using whenever we get this thing up and running. But let me see if I can put this thing on while I'm holding the fan, or holding the camera. Okay, so it should power up. Battery may be dead. I'll leave this thing on. There we go. So it powers up. There's our little splash screen. And now we've got a voltage reading and then thresholds for our 3 channels. Even though this has technically 4 channels for the relays, we're only using the 3, so we'll have like upshift, downshift, and horn. And then one of them is a DC input to power this thing. So by default, these things want to be powered by 5 volts, but by running this relay board, as I toss it across the car, by running this relay board, you can actually power this thing off of basically up to 30 volts. I think it's, 10 to 30 volts. But I don't know how well you'll be able to see. We got threshold values that we can change. And then we've got the output status. So right now it's set to like 2.5, 3.5, 4.5. And the nice thing about this is we can update it once we get this thing in. I don't have to hook the laptop up. I can update it, hit a paddle, see what the voltage is, then make the adjustment to the output that I want for that voltage. Now on top of it, I made it where if you hold both buttons, it brings up a pop-up menu that allows you to adjust deadband. And that's going to be like the area in which the trigger works. And so right now it's set to, actually I have it set to 0.1 volt plus or minus, and then delay to give you debounce essentially. So you want to make sure that if you don't have that delay in there, whenever it's passing one of these other thresholds, it can trigger it. And that's what doesn't work very well in the Turbolamic setup, is that delay. I get the horn beeps a lot, or I get a lot of downshifts even whenever I'm trying to upshift. And so I just decided to ditch it now. This setup, like entire setup, cost about $70. Maker World stuff, like these small electronic things, are just getting stupid cheap, and you can do awesome stuff. I did most of the programming with this with the assistance of ChatGPT. So it only took a couple days. So if you run into issues where you're trying to get something to work, man, this is always a great kind of solution. There's a lot of these solutions out there that we're just not even aware of that we can make work and do some cool stuff with. And in fact, I've got a different console. Excuse the mess. As I said, it's been pretty busy. We're still on the old 3D printer over here, but you can see I've printed a new plate. Hold on, I have to put the camera down. I printed a new plate that will mount that unit on there. And so there you can see I did a cutout for that. I need to take the supports out. Got to be careful with this. This is with some of that carbon fiber stuff, so it's not the best on these things. Will snap off, but other than that, once it's all together, it'll be held in place real nice. And that's what we're going to be going back in with. But for right now, let me get the existing cover off and let's get down to the wiring. I need to clean up some of the wiring anyways for the stereo. And while we're in there, we'll install the new plate, which I made with using the Metro X scanner and just kind of laid it out and scanned in all of my things that I needed to mount. And there's actually some holes in here already that you can't really see. But the cool thing is I used a carbon fiber looking print surface, and so it gives it this cool carbon fiber look whenever you print it out, at least on the first layer. I've got our back shell off of our Turbolamic connector. This is our horn signal, so I can just go ahead and cut this. This is a digital out. I'll cut it somewhere short. I could depan this, but I'm not worried about it because it's turned off in the software. It's not going to interfere with anything. This is our power, our 5-volt power essentially to the mux, the multiplexer, and this is the return. So this is where I'm going to cut this, and we'll want to extend this wire and run it to the new module. Now these two wires are already wired into this terminal, and this is the digital input for paddle upshift and downshift. So we'll have to extend these out and run these over to the new module. And what you'll see what I did on the module here is I've got my ground loops wired up. So we'll bring power in. I'm going to add there's plenty of auxiliary power pins on this, so we can power this directly off the Turbolamic. My grounds are looped, so I'll bring power in. Then there's one of my outputs for a paddle, another output for a paddle, output for the horn, which is going to be this purple wire. And then I've got an additional leg that'll go over here and tie into ground on the voltmeter. We'll tie those into chassis ground. This will be chassis ground. And then, as I said, we'll add a pin in here to get power out. So let me work on extending these where they need to be extended. So almost everything needs to be extended because this thing is going to be mounted up in the center console, and then we'll jump back in from there. So unit should power on. Hey, we're good to go there. So there we go. As you can see, we've got 5.09 volts. I'm going to hit the downshift paddle. It drops us to 4.19. Upshift, 3.505. So We know the upshift needs to be number 1, so I can go ahead and edit. Let's make this one 3.5. And I can do that to see exactly where it's at. 350. Okay. And we'll go down to our downshift, which is basically 4.19, so 4.2. So I'll edit this one. We'll go up to 4.1. Let's do 4.15 because that seems to be, if that doesn't work, I can go to 4.2. That's going to be close. Yeah, we'll leave it at 4.2. Then last but not least, the horn, 2.7. So we'll go down, lower this one to 2.7. We'll get the dogs barking whenever this works because this should honk the horn. Okay, 259. We need to go down a little bit more. And I might have to broaden the threshold just for number 3 because that, going through the horn button, there we go. Going through the horn button seems to have more room for error, but everything should be looking good. So can you see those statuses? Upshift, downshift. So let's lower. Let's lower our delay. I'm going to try and set it at 50. And we want to run the shortest delay that we can that does not cause other outputs to trigger on. So like right now, we're doing the upshift, which is output 1. We just want to make sure that it's enough delay that it doesn't output 2 because that's at 4.2 volts. So we're going down to 3.5 for this one. And we can try and go lower. But we would get to a point where it would start passing. Whenever that voltage passes, it would be without enough deadband, it would trigger that. Now, obviously, as I said, we want the shortest deadband because we're dealing with paddle shifts. We don't have a way of doing both, but I don't think there's ever a situation where we need to hold both paddles in on this. If there were, we could then utilize our 4th relay and set that to 3.05 and have both paddles being held down. So that all looks good. So I'm going to clean this up, button up all this wiring, try and get it as tidy as possible. It's looking a lot better already for as much wiring as we've got going on this. Ugh, I hate radio harnesses. And get the center console put back together. I ran into a couple small problems. One, it's not retaining settings, so I've got to go back and look at the code. And 2, my mounting location is very restricted. It's only going to fit right there. I had it down there, as you can see, with the new plate. Let me just grab it. I didn't think it was going to fit right there, but apparently it will. What do you guys think? As said, I've got to update the program on this, and then we'll put all the parts in and button it all back up. Okay, it looks like I've got the logic in place now where we should be able to set this up. So one is our upshift. Our upshift is 3.495. So let's go ahead and try this again. Lower our delay. I think we had it 50 milliseconds and everything was looking good. Debounce, 500 milliseconds. Debounce is what whenever we're leaving, it keeps it from triggering twice. I added that. Set my deadband back down to 10. Okay, so I'm going to cycle this off now. We'll give it time to shut down. As it says, it's being powered off turbolamic, so turbolamic stays on for a few seconds, 30 seconds or a minute, and that's to save the adaptives. This uses transmission adaptives like a modern TCU. So this thing should kick off, and then we're looking to see that we have 350, 415, and 265 whenever we power back up. .350, 415, 265, upshift, downshift, horn. We're good to go on this. Now, my freshly printed out plate, I made the shifter hole too small, so I'm going to have to, the old one was too big. So I actually went in and reduced this by 2%. Should have only done 1%, needs to be 1% bigger, but everything else is good. Let me check. We can kind of pop out, like the big one is this display. That gives us our reading from the turbo lamp, lets us know what gear we're in. And I thought about tying that into this device. They make a CAN module, but it would start getting pretty deep. We've got this little display to let us know for right now. I might add one later on, who knows? But that's the big thing. Everything else we can fix. So, okay, so I'm going to get back to tweaking my print file for this thing and print out a new one. But hopefully you can see like what $70 and a little bit of your time can produce. This thing is pretty awesome because it can be adjusted on the fly as things change to make sure that you have proper voltage, you know, adjust all the delay and debounce settings and stuff like that. So now our paddle should be good to go. I may have to make a couple tweaks on the turbolamic software side to look at the digital inputs, but that's not a big ordeal. That's all simple stuff, and we should be sorted out. This also gives us access to things like trans brake. I think I talked earlier about needing both paddles. I think we may need that for bump. I'll have to look more into that. But as I said, we still have that fourth relay output that we can set up as another output that could be something like bump, because I don't really see anything else on here. The big thing is just our paddle up, paddle down. But as I said, if you have an idea of something that you need to get accomplished, don't be afraid to go out and grab something like this, because with technology the way it is nowadays, with Chat GPT and all the AIs out there, doing the custom programming on this stuff is super simple, easy. It walks you through it. There's a lot of trial and error. I find that what I run into the most is whenever I'm doing these things, it just will end up getting stupid. So save milestones, like if you get one thing working. Whenever I did this process, what I did was, here, let me just set this thing down so I'm not having to hold it. How do I? It's been so long since I filmed myself. So when you're going through this process, set milestones. Whenever I did the design process on this, I went through and designed the graphical user interface first. I hadn't had the relay module yet. I'm sorry if you can hear the birds out there. That is our woodpecker repellent. I live in a wood house. Woodpeckers are going after it. I got to get somebody out to check for termites, see what the hell's going on. But save milestones. So if you get one step done, milestone it, save it as a separate file, whatever program that you're using for the programming stuff, because you might get down a path where AI starts losing its mind and it does dumb stuff. You'll need to walk it back and kind of walk through those steps again. That's my number one takeaway. You don't have to know how to program. This thing will tell you, you can go on to ChatGPT and say, this is what I'm trying to do. Give me some options, suggestions of devices that I can do this with. Now, they didn't suggest the M5 stack to me. I went out and found that actually for a different project that we'll talk about down the road. I went out and dug that up, and then while I was planning on that project, I was like, wait, this would work great for the multiplexer for the paddle shifters on the Camaro. Because as I said, I got them working somewhat through the turbolammic, but I just didn't like the integration. Some of the tables, as far as the voltage targets, were hidden. I had to go in and find those tables out. But even then, I was getting issues with, like, whenever you would pull a paddle and it would say it was going down to 2.5 or something like that, it would trigger the 4.5 and the 3.5 volt triggers. So there was no delay, dead bounce, or dead bounce, delay, dead band, or debounce settings really in there. I hope they update that on a future firmware revision. There's no reason why it shouldn't be in there. But on top of it, I just won't get into that. Listen, that's the only complaint I've had about the turbolammic transmission controller so far. I've got a couple 100 miles on this thing now. The transmission's amazing. As I said, this is the best swap. The ZF8 HP 70, 90, whichever one you need, is the best transmission swap you can do on a car right now. This transmission just shifts super fast. It's great. And I haven't even put it in theoretical sport mode. I'm just running it in base default mode, and I'm absolutely in love with it. So there's a good chance in the future you'll see me do another integration with the turbolammic. But other than that, man, you know, the console turned out great. We can kind of take another glance. The cup holders, obviously the top plate's not on there, but that was, what I did was I just came in with the Metro X and just scanned everything and then laid that into Fusion so I could see where I needed my clearances all the way up to, you know, it goes all the way up underneath the dash to kind of help hide wires and stuff like that, and just started designing off of that. So honestly, I mean, just couldn't do it without a 3D scanner. And so I'm sure in a future video, you'll see the finished product where everything's hooked back up and it's nice and clean and it looks great. So, but that's it for now. I'm going to get back to it. I got a lot more work to do. You guys know the drill. Thanks for stopping by the garage. Remember, ABT, always be tuning.